Having completed infrastructural design, we have a basic empty room to fill. We'll now focus on adding cabinets to the facility. We'll make use of the integrated Six Sigma library, which holds over 2,000 cabinets, servers, PDUs and ACUs to aid in quick and easy population of your virtual facility. Rather than dragging one cabinet at a time from the library, we can use the layout tool, which allows us to arrange large areas of the data center quickly. The layout tool lays out cabinets in the standard hot aisle, cold aisle configuration, but is flexible enough to work for other configurations. It can be used as many times as you require to allow different areas of the data center to be populated. The purple represents the floor grills. Cabinets are shown in white with blue for the front and red for the back. Cabinets can be orientated across or through the room. We'll stick with through in this case. The aisle length, width and separation can all be changed to allow for any configuration to be set up. The start location is click-based, so we can lay out the cabinets in any position. We'll locate these aisles on tile D4 with length 16, width 2 and separation 5. We can have full end aisles or half ones. In this case, we'll have full. The default floor grill is selected, but you can use the library of floor grills to populate the virtual facility with your preferred grill selection. We can do the same for the cabinets. Cabinets can be found in the main library or in any other library you may have created or received from a consultant. Often detailed cabinets would be modelled in Six Sigma rack and then dragged into a common library to be used for virtual facility models in Six Sigma room. In this case, we'll choose a generic cabinet by clicking on the cabinet and selecting from the demonstration library. If you make a mistake, you can undo and then redo the layout tool, and it will have remembered all your settings so you can make slight tweaks to the layout. You should be able to see 6 rows of the default cabinet. We'll add the next row of cabinets in the same way as before by using the Layout Manager. This time we'll do a single aisle with cabinets only on the left-hand side. The start point for this row is set at tile Y4. Once cabinets are placed, you can adjust their location by any amount. We'll make this row of cabinets overlap the floor grills by 0.2 metres. The next 2 rows of cabinets are set up again using the Layout Manager, but this time setting the end aisles to half, cabinets to both rows, and selecting the cabinet from the demo library. In the next row of equipment, we'll add cabinets which are of different types and in different positions. In this instance, we'll use the Layout tool simply to give a row location, so no actual cabinets are required in the row to start with. We'll do this by selecting the Layout tool, then setting Cabinet to None. We'll then set the cabinet layout to Right. This ensures that all cabinets placed in the row will be orientated correctly. Making the aisle width 1 will give us 1 row of grills. We can then line up the row next to the final tiles. In this row we'll have vendor-specific equipment which sits in a cluster of 3. If we select the row AH4, add a cluster and then drag in a 900, an E25K and then a 900, you'll notice they all sit next to each other and face in the right direction. You can move the cluster to attain the desired placement. can now pattern the cluster to get 4 in the row. With many cabinets which are supplied fully populated by vendors, there are required grille arrangements that must be adhered to in order to provide adequate cooling. In this instance, the Sunny 25K needs 2 grilles underneath and 2 at the back. The best way to do this is to use the pattern tool. The procedure can be repeated for the 3 other Sun cabinets. For the last row of equipment, we're going to add some clusters of EMC DMX 3000 cabinets. Using the layout tool, we can change the aisle width to 2 and select the start grille as AM4. Again, we'll lay out 2 rows of grilles, but no cabinets, as we'll drop the clusters into the correct location. Now we'll drag an EMC DMX 3000 cluster from the library into the row. You can add more by copying and pasting. Now that we have all the cabinets installed in the room, we can install some cable trays underneath the raised floor. To allow us to see beneath the raised floor, we'll change its display option to wireframe. When you select the room and add new data cable, the next dialog allows you to run multiple routes at the same time. It's easy to draw cable routes by simply clicking through the locations you require. We're going to run the data cables underneath each row of cabinets by selecting the main run, creating branches and clicking under the end cabinets. By pressing Escape each time, you can continue to add cable branches to the main cable route. We'll also add a few cable branches that run out of the bottom of the room. Now let's look at our cable tray in a bit more detail. If we select the data cable, you can see it is 450mm wide, 100mm high and 300mm above the slab. Branches inherently take the size of the main route, but you can change the size and height off the floor of each cable branch. The construction options let you specify further details such as cable type, tray type and cable density, which is important for airflow modelling.